In video number 3, we'll take a look at some patterns that have to do with shapes. And even with these patterns that use shapes, we can still maybe find a pattern with numbers, right? So what we're going to do with 10 and 11 is we're going to look to see, can we spot the pattern geometrically with the shapes? And then is there a pattern with the numbers? That's what we're going to look for. We're going to start with number 1 because it seems pretty straightforward, I think. Let's see. We have different circles, different dots, right? In the first term, I only have one circle. In the second term, I have 3 circles. In the third term, I have 6 circles. In the fourth term, I have 10 circles. So the question is, what is my fifth term going to look like? How many circles is it going to have? Well, if you look carefully, really, we're just taking the previous term and adding an extra row on the bottom, right? We're taking the previous term, or I guess I should say the previous term, and adding an extra row on the bottom. We're just taking the previous term and adding an extra row on the bottom. So the next one should have the same amount of circles as the fourth term. But an extra row on the bottom. Do you see how the circles, I can only put a circle in between 2 on the top, right? I can only put a circle in between. So I'm putting, the last row had 4, 1, 2, 3, 4. I'm putting a circle in between, and then one at the end and one at the other end. So total, how many circles do I have? Well, if you count them up, you're going to get 15. So the question is, I don't want to see what the 10th term is, but I want to know how many dots there are in the 10th term. So is there a pattern with these numbers, with this sequence of values? 1, 3, 6, 10, 15. What's happening to get from 1 to 3, 3 to 6, 6 to... Can you tell what's happening? Well, if you're paying attention to what's going on here, we added an extra row. We added an extra row. We added, and every row that we add has an extra dot. So we're adding consecutive whole numbers this time. We're not multiplying consecutive whole numbers, we're adding. So 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. So to get to the 6th term, we're going to add 6. To get to the 7th term, we're going to add 7 to whatever we got before, and keep on going that way. So using my handy-dandy calculator, let's see if we can figure that out. Do it. So we started with 1. We add 2, and this is the second term. We add 3, and this is the third term. We add 4, fourth term. We add 5, fifth term. 6th term, 7th term, 8th term, 9th term, 10th term. So there should be 55 dots in that little pattern of triangular pattern that would be needed to create the 10th term. I'm not going to ask you to draw it. I just want to know how many dots there would have to be. And we can figure that out without drawing it because we're looking at the numbers, and the numbers follow a pattern, which is the whole idea of today's topic. It turns out these numbers, 1, 3, 5, 1, 3, 6, 10, 15, and so on, are called triangular numbers. And the reason they're called triangular numbers, it's because this is the amount of objects, in this case dots, that you need in order to build a triangle shape with those objects. So I need 6 objects or 6 dots in order to create a triangle. I need 3 dots in order to create a triangle. I need 10 dots in order to create a triangle. I need 55 dots or whatever other shape to create a triangle of those shapes. These are called triangular numbers. Number 11 Ooh, there's different ways to look at number 11. Let's see. Can you tell me what the fifth term looks like? Can you tell me how many terms there are in the fifth term? And can you predict how many squares there are in the 10th term? Well, let's see how many squares are there in the first term here. 1, 2, 3, 4, 5. In the second term, 1, 2, 3, 4, 5, 6, 7, 8. In the third term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In the fourth term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is there a pattern with the numbers to get from the first term, which is 5 squares, to the second term, which is 8 squares, 11 squares, 14 squares? What's happening every time? Well, it looks like we're adding 3 every time. If we're adding 3 every time, then the fifth term should have 17 squares in order to draw it. And we're going to draw it. And then the question is, how many squares are there in the 10th term? But let's draw the fifth term. Now, how are you going to do that? If you notice, the second term, let me use the highlighter. This is the first term. The second term is just whatever the first term is with 3 more boxes, right? And then when I look at the third term is just whatever the second term is with 3 more boxes. So it's always the previous shape plus 3 more boxes. So to draw the fifth term, let me use a darker. I'm going to need, let's see. So that's this part. And then we'll keep going. It's almost like a little Tetris piece here. This part, and then keep going. Oh no, I made them not the same size. That would be this part. But then I'm supposed to add another 3, so it'll be 1, 2, 3. And if I count all of these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, that's the number that we got. It works. Great. But how do we find the 10th term? Well, now we know what the pattern is. We just keep adding 3 until we get to the 10th term. So the fifth term has 17. The fifth term has 17 plus 3, that's going to be the sixth term. Plus 3 is going to be the seventh term. Eighth term, ninth term, 10th term has 32 squares. So there are 32 squares. How many squares? There's 32 squares in the 10th term. And we can figure that out by just adding 3 more each time that we go. When we get to number 12, I'm going to ask you to do number 12. Number 12 is not necessarily you're adding objects, but there is a pattern here with these 4 triangles. Can you draw the fifth triangle? And then can you figure out what the 10th triangle would look like, the 10th term triangle would look like? Go ahead and work on that with your partner and see if you can figure that out.